Ensuring application security is a very important thing to do, but it's also often very tedious and definitely not fun to do. The tools we use are usually slow and not very accurate, and this leads to not use them properly or not to use them at all. Notice that I've said usually, because I think I've found the solution for it. Or better, Snyk has found it. Let's dive into it. Hi everybody, welcome back to CoderDave. Today we talk about Snyk and how to use their security suite, and especially the newly announced Snyk Code, to keep our applications secure. This video is fairly long, so feel free to use the timestamps you find in the video description to jump between the different sections. However, I would recommend you to watch the entire video because it's packed with very useful information. To better understand where to position Snyk and how it helps, we need to take a look at the current issues we face. There are many tools out there that can take care of the different phases of application security, but as I've mentioned in the intro, they are usually pretty slow and not very accurate. And this is a problem. In the DevSecOps practices, you want to shift left on security, meaning that you want your application code to be scanned and made secure as soon as possible in the development cycle. If the tool you're using is too slow, then it will waste your precious development time or the time during the CI in a pull request. Similarly, if the results of the tool are not accurate, for example, it returns too many false positives, or even worse, if the tool regularly misses potential vulnerabilities, your confidence in the tool itself will decrease. Because of those aspects, you may end up not using the tools at all, exposing your code and your application to greater risks. So what makes Snyk different? Well, first of all, their philosophy. They have a unique combination of developer-first tooling and best-in-class security depth, and I want to emphasize the developers first bit, because this is very important. All the Snyk tools are developed with the developers in mind, and that means they will try and solve all the common adoption blockers we've just seen. Second thing that makes Snyk different is that they provide a comprehensive end-to-end platform, which they call Cloud Native Application Security Platform, which includes basically almost all you need for making your code secure. This platform in fact includes their open source security that automatically finds, prioritizes and fixes vulnerabilities in the open source dependencies, code security, which we'll explore more in depth later, container security to find and automatically fix vulnerabilities in your containers, and even infrastructure as code security that focuses on issues and vulnerabilities for Terraform and Kubernetes definitions. As I've mentioned, we will go deeper into the new Snyk code a little bit later in the video, but let me show you now how these other tools work and what they can do for us. Alright, here we have a project which I've imported before. As you can see, it's very immediate to understand that we have some problems on this project. The first field represents the high severity issues, the second one the medium severity issues, and the last one the low severity issues. We can also see that we can filter the projects based on various parameters. By default, we only see the projects that do have issues and that are active in the system, but we can also filter by how critical the vulnerabilities are and by other parameters that we can see later. This project that I have here, it's imported from GitHub, as you can see from the logo, and is an interesting project because let me show you two different things: the OSS vulnerabilities for the dependencies and the infrastructure as code. In fact, as you can see, I have three sub-projects in this overall big project. One is Docker file, and the other two are YAML files from Kubernetes. Let's take a look at the Docker file first. This section on top of the page is where we can further categorize our project for an easier search in the page we've just seen before. But all the important stuff are lower in the page because it's where we have all the vulnerabilities listed and summarized. As you can see, I have a bunch of vulnerabilities here, but you can also see that the majority of those come from the usage of an old container image. And this is pretty cool because, as you can imagine, in a context of this type, the application vulnerabilities are just one of the problems that I may encounter. But in this case, I have vulnerabilities coming from all over the place due to the dependencies I have in my Docker image, in my version of Node I'm using, and so on and so forth. All the vulnerabilities you see here have a score, so you can immediately see what are the most critical ones and what are not. You can see that I have multiple times the git man listed out, and this is because we do have different vulnerability bulletins for each of the entries. I can of course filter all those vulnerabilities based on severity, how fixable is the vulnerability, maturity, and so on and so forth. And for each of those issues, I can click on Show More Details. And this gives me a lot of more details, as the name says, on where the issues is, where it's been introduced, what the remediation could be, and a general overview of the issue itself. And if you're asking yourself how this works, if I click on dependencies, you see that it's building the dependency tree, and it's correlating that with all the information Snyk has in their vulnerability database. And you have here the whole tree of vulnerabilities with all the information you want and the different vulnerabilities categories for each one. Let's scroll up again. So we can see another very cool thing, which is this Open a Fix PR button over here. In fact, if you look over here, you see that we already have a major upgrade suggested for the base image I'm using. If I want to update to that, what I can do is click on Open a Fix PR. And since my project is connected to GitHub, it will open for me a pull request with the Docker base image, as you can see here, in my project. And not only I have the pull request opened, but I have in here all the details and reasons why this pull request has been opened. And this is pretty cool because it saves you a lot of time. Let's go back to Snyk. I do have another Show More upgrade types, which I can use, and actually I may decide to go with another base image that has less vulnerabilities. Let's go back now to the project page and let's pick the other project. For example, let's get the deployment manifest for Kubernetes. The header is very similar. And here, not only I have the list of vulnerabilities I'm exposed to, but I even have the line of the YAML file where that vulnerability occurs. For example, I can see here that my container is running with the default set of capabilities. If I want to know more about these vulnerabilities, which is a medium level vulnerability, I can click on this. The line will be highlighted and I have here the details of this vulnerability. And in fact, I can check the impact of the vulnerability and even how can I resolve this problem. And of course, you can decide to solve the problem or to ignore it, even though I would not recommend that. This is really complete and gives you a lot of information about the status of your application and your infrastructure as code. If I go to the History tab, I can see the history of all the scans this project has been through. I can tweak the settings for this specific project, like how frequently I want it to be tested, notification settings, and so on and so forth. That was pretty cool, and I think it works very well too. By the way, if you were thinking, what is the difference between Snyk open source and GitHub Dependabot? Well, subscribe and stay tuned because I have another video coming out on that soon. Next, I want to talk about the star of the show, Snyk Code. But before we do that, hit the like button below if you're enjoying this video or you find it insightful. This will help this video to be recommended to more viewers so they can benefit from it and will really mean a lot to me. Right, so what is Snyk Code and why I think it's really important? Snyk Code is a static application security testing tool, or SAST, but unlike other SAST in the market, which are designed primarily to test applications post-development, Snyk Code is being deployed with a developer's first approach. And this means that not only it provides a very user-friendly experience and integration with DevTools, but it's also pretty fast with near real-time scan results and has a high accuracy. And it can be all of this because it integrates into your IDEs like VS Code, Visual Studio, Eclipse, and others, more on this later, and also because it's powered by machine learning and AI. The Snyk Code AI engine learns from millions of open source commits, and is paired with known issues from the Snyk's Security Intelligence database, creating a continually growing code security knowledge base. But enough talking, let's see this in action. We will see first a more traditional approach, and then we will try to push it to its limits, shifting left as much as we can. Before we can see how Snyk Code works, we need to, of course, enable it. To do so, we go to the settings, we navigate down to Snyk Code, and in here we have the control to enable the Snyk Code. Just click on it and save the changes. It's important to notice that Snyk Code is only enabled from this point onwards. So if you had imported before some project that you want to activate Snyk Code onto, you need to re-import the project. We will come back to the settings page later on for some tips, but let's now import a project so we can have Snyk Code working on it and can see that process as well. The easiest way to start with Snyk Code is to add a project from the interface. You can do it from GitHub using the CLI or other sources that we'll explore later. Let's click on GitHub because my project is on GitHub, and let me select the project I want to import. For this example, I will import this Smart Hotel 360 website, so I select it, and then I just click on Add Selected Repositories. Snyk will import the code and start scanning for it in just a few seconds. Here it is. As I've said before, there are other ways to have Snyk working on your code, like the integration with the IDEs, CIs, etc., but we will explore them later. Let's now take a look at what we have here. If I open this up, you can see that, like before, we have the different projects that Snyk has scanned for vulnerabilities, but we also have this new code analysis tab over here, and this is where Snyk Code performs its magic. Let's click on it. And here we can see that we can filter by language. In this case, all the 3 vulnerabilities I have come from JavaScript, but should I have a different set of vulnerabilities depending on other languages, I would have here the choice to filter by language. And similar to what we've seen before, we have the list of vulnerability, and for each one, apart from seeing exactly in what line of code that vulnerability occurs, I have an explanation of why that vulnerability is important. And if I click on the full details, I have even more data that I can refer to. Let me show you an example on another language. Here we have this Java application, and if I filter by Java, you can see that we have this vulnerability over here, and going to the full details, I can see exactly where the vulnerability is and what is causing the problem. I can also see the security bulletins that are associated with this specific vulnerability and visit the pages for each of those. Finally, let's see a Python application. And here we can see that not only Snyk Code is able to identify vulnerabilities related to the code, but also if you have secrets in your code. In fact, if we click on the full details, it's even better than that, because not only it identifies that we have a hard-coded value that is most likely a secret, but also how it is used. In this case, it's used as a cipher key in this cryptography library and is able to identify it from the context in the code. And finally, Snyk Code is also able to provide us recommendations on how we should solve this particular problem. In this case, not use a hard-coded value, but use a strong random number generator. And I've shown you applications in Python, Java, and JavaScript because these 3 languages, together with TypeScript, are the ones supported by Snyk Code at the time of recording this video. Let's now take it a step forward and try to automate it using the Snyk CLI and also integrating it in our CI. Let's start with the CLI first. I don't have the CLI installed yet, so what I have to do is going to add project and select CLI. We can install it via npm, via brew on Linux or Mac, and via scoop on Windows. I will use the npm installation, and this will install the CLI globally on my machine. This takes just a few moments, and next step is the authentication, the Snyk auth, and execute it. And this will open browser page for me to authenticate. Since I'm already logged in, I click on authenticate, and my account is authenticated automatically. Now all I have left to do is going into the application folder and launch the scan using the Snyk monitor command. This will start the scan, and after it's finished, we will be given a URL where we can see the scan results. This will take only a few seconds. And in fact, now it's done. As you can imagine, this is very useful to launch it like as I've just done as an extemporary measure, but it's also pretty cool to be scripted, so you can add this as part of your build script or your testing environment, for example. Let's visit the link. Let's make this bigger. You can see that I've just received an email with the vulnerability that I have in my project. And in fact, I can see here that I have a bunch of vulnerabilities in this project. Since Snyk knows that these come from a CLI, it also advises us to use the Snyk wizard to explore the remediation options. So let's go back to our CLI and see what that does. Let's run the Snyk wizard. And as you can see on screen, this will perform several tasks. We'll enumerate our dependencies, it will guide us through fixing the vulnerabilities, and it will create a Snyk policy file for the other Snyk command. And finally, of course, we'll remember our dependencies so we can be alerted when new vulnerabilities are disclosed. For each vulnerability, we'll give us some remediation option. That could be to reinstall the dependency, because this will trigger an update. Could be to patch it, even though in this case there is no patch available, or we can ignore it for 30 days. We can also skip and fix it later. Let's try to reinstall it just for the sake of doing it, and we can so continue with the other vulnerabilities. One thing that I really like here is that, for example, when it tries to upgrade Electron, it advises us that this change is potentially a breaking change, so we can decide how to approach this. Let's stop this here and let's see how we can integrate these with GitHub Actions. Here we are in GitHub Actions and we have this workflow to build our Python application. Now, if I want to add Snyk to this workflow, I have two options. The first one is to use this Snyk Action Setup task, which basically sets up the CLI, and then I can use the CLI as I would do on my local machine. But this time, instead of using the Snyk monitor, I want to use the Snyk test command. Differently from Snyk monitor that uploads the code to Snyk and keep all my code continuously under control, Snyk test performs the scan just once, and notice that we need to pass the Snyk token, which I've saved in my secrets, and that can be retrieved from your user account settings or from your organization settings. Let's save and run this action. The workflow is running, it's installed the Snyk CLI, and now it's running the test. And we can see that it failed, and if we scroll down, we can see that it failed because it found 3 issues with 6 vulnerability paths. And we have both code issues and license issues. The other approach we can take, instead of using the Snyk test directly, is to use the Python action the Snyk has available. You can see it's the same Snyk/actions, and then we have the language, in this case Python. It still uses the Snyk token, so remember to add that. We can integrate this with the GitHub code scanning alert to publish the sorry file as an output, and then we can use this other action from GitHub, which uploads the results to the GitHub code scanning alert. We also need to make sure this action continues on error, otherwise our workflow will stop here because of the vulnerabilities and issues that it will find. Let's save these and see our workflow in action. If we go and check the scan results, we can see that we have the same issues we've had before, and we can also see that the sorry file has been uploaded into GitHub code scanning. Let's see the results. We go to security, code scanning alerts, we have 6 notifications, and we will see here all the different vulnerabilities that Snyk has detected. Finally, let's see this integration with Azure Pipelines. First thing we have to do in Azure DevOps to be able to use Snyk is going to the extensions and browse the marketplace. Then search for Snyk Security Scan, the first one here, and click on Get it for free. We can install it in our organization and we're good to go. Next thing is to create a service connection for Snyk to be able to authenticate. With the extension that we've just installed, we can now find here the Snyk authentication type of service connection. And all we have to do in here is basically just paste your API token that you can generate, as we've seen before, from Snyk directly, and give it a name. Save this, and now we're good to go. Let's go to our pipeline. I have a pipeline here, and I'm actually using the classic UI pipelines just for a change. And this build the Java application that I want to test. Add a new task, and I will search for Snyk. We have this Snyk security scan, and we can add this to our pipeline. I want to add it just right after the build. And if you see, it asks for Snyk API token, which is not entirely correct because you cannot paste the token here, but you have to select the service connection we've just created. We can decide what we want to test, if the application, like in this case, or a container image. We can specify a custom path to a manifest file and the testing threshold for the severity. We can also decide if you want to enable the Snyk monitor that, as I said before, will upload your application to Snyk and keep it under continuous monitoring, and if you want to fail the build in case Snyk finds any issue. When you enable monitor, you can also specify a project name in Snyk, and can either be a new project or an existing project. And lastly, you want to use the organization you have in Snyk for reporting this project. Save and queue. And we can see that once again, it uses the Snyk test with the parameters that we've basically passed when we were configuring the task. As we can see, the scan has failed. Let's see why. We can see straight away that the message is that Snyk has found issues. So let's scroll up. And in fact, we can see that we have all the issues here with all the links to them. Let's try to open this one. And we can see that this links to the vulnerability DB in which we have all the details about this vulnerability. Let's go back to the pipeline. And for each of these vulnerabilities, we can also see the recommendations on how to fix them. For example, we can see that to fix all of those vulnerabilities, the recommendation is to upgrade from this version of this plugin to this version of the same plugin. So we have this already directly in the log in Azure DevOps Pipelines. That was really cool. If you're wondering how Snyk Code compares to GitHub code scanning, consider subscribing and stick around because I will have a video about that coming out soon. Let's see now how we can shift left on security using Snyk Code, or if you want to say it differently, how we can use its features very early in the development process without even pushing our code to the repo. We can integrate Snyk with a lot of different IDEs like VS Code, Eclipse, IntelliJ, Android Studios, and many others. For my example, I will use VS Code, but keep in mind that the integration works similarly for all the other IDEs. To integrate with your IDE, you would need to install an extension or a plugin. For VS Code, it's in extensions and you search for vuln-cost. When you click on it, you see it's the Snyk extension, and for the time being, it covers JavaScript and TypeScript. The language support differs between other IDEs, so if you're using anything else, go and check the integration page that we will cover in a second. So let's install this extension. And now that we have it, let's check our code. Let's go, for example, to this Node.js application. You can see that we have these scanning fault vulnerabilities, one vulnerability detected, and so on and so forth. Now, if I mouse over this vulnerability, you can see that this Swaggerized Express has two medium vulnerabilities. I can view the problem, or I can also try and quick fix it. I can click on this fix vuln, and unfortunately, we don't have actual remediation available for this specific vulnerability, but at least we have a reference to the problem, so I can always follow the link to the page in the vulnerability DB as we have seen before. That was super easy. I think you can see now the real value of Snyk and why I think it's a game changer. We are almost done, but there are two more things I want to talk about. First one is other integrations, and then we will see some settings and some tips about settings. You can visit the integrations page within your account to have a list of all of them, and the list is growing constantly. You can also see from this page which integrations you've already configured, like this GitHub in my case, and you can control the integrations from here. Let's say, for example, that you want to integrate with Azure repos. You can click on it, enter your URL and credentials, and the integration will be set. In other cases, like for Azure Pipelines, it will provide you a step-by-step guide on how to do the integration because it happens on the third-party service. Let me go through just a few of them. On source control, we have all the major source controls in the industry. We can integrate with container services to scan directly your containers from within this platform. Same thing for the container orchestrators. We can connect to Kubernetes. You can start the integration from here, and this will automatically scan your containers running on Kubernetes. We have the integration with various continuous integration platforms. We've seen the integration with VS Code, but as I mentioned, you can go with Eclipse, Android Studio, and many others. And the language support actually depends on the different integration and a different IDE. We can go for package repositories. We can even integrate into serverless systems, and this will scan your code that is actually deployed in the serverless platform. Supports PaaS, and can even integrate with Slack and Jira to send notifications. And finally, with other vulnerability managers, if you prefer having a single pane of glass to see all your vulnerabilities and security issues. This video is already long enough, so I don't have enough time to go through all of those integrations. But let me know in the comment section below if you want me to create another video about some specific integration you're interested into. Finally, let me show you some settings and let's talk about some best practices around them. First setting I want to talk about is this ignore section. By default, all users in an environment are able to ignore issues or edit the ignore settings, but you can always restrict them only to admin users. But even if you don't want to do so, what I would recommend is enabling this require reason for each ignore, because at least you know why that specific user decided to ignore that issue, since that can be potentially dangerous. Another interesting section is the integration sections. As we've seen before, if we go to integration, we can see the status of all integrations, but it's in here that you can actually edit all the settings for each specific integration. One thing I find interesting is that if I edit the settings for GitHub, the ability which is enabled by default to have Snyk tests running as a check in our pull request. I would probably recommend enabling the failing of a PR only for high severity issues. Finally, you can also decide to let Snyk automatically fix pull request. By default is enabled only for new vulnerabilities, meaning new vulnerabilities found since the last test, but you can enable it also for old vulnerabilities should you want to. You can customize the behavior of the tool for the different languages. Then we have this Snyk Code and infrastructure as code, which is where you're going to enable, as we've seen before, those features. And finally, a pro tip. If we go back to projects, you can see that if you want to remove one of these project groups, you need to remove each of the projects inside. For example, let's say I want to remove this project over here. I will need to go inside each one of these projects and delete it. And this could take a bit of time. The pro tip would be go to settings, go to usage, and in here you have the complete list of your projects. So if I search again for the project I wanted to delete, you can see that the list is now filtered and I can select all the projects I want to delete and bulk delete them. Of course, with confirmation, and done. Much easier. Alright, I think it's more than enough for today. As we've seen, Snyk has a very comprehensive portfolio of tools that we can use to secure our code and our applications, and I think Snyk Code is a very powerful addition to that suite. I really love we can use it in a more traditional way, just adding our projects and repo to it to be scanned, but also that we can integrate it easily in our continuous integration. And I think that you probably agree with me that its best feature is to be able to do the scanning in near real time, so we can integrate that very early in our development workflow. Let me know in the comment section below what your thoughts are, and as I said before, if you want to see some other integrations that I haven't covered in this video. Also, as I said before, remember that I will soon have other videos coming out on this subject, so consider subscribing if this is something you're into. Finally, you may want to check this video over here, in which I go through how you can approach security issues in a DevOps context. But that's it for me. Thanks so much for watching. I really hope you enjoyed it. Hit the like button below, subscribe if you haven't already, and I see you in the next video here at CoderDave.